So let us begin our today's session. The objective of today's session will be on the chapter cone. So the contents what we are reviewing in this chapter have the following constraints. One, we are taking at the basics, that is what is a cone, how do we formulate a cone, and problems based on that. The second part, what we are doing is cone having three mutually perpendicular generators. The third part is plane section of a cone. Then we discuss about enveloping cone. Then we discuss about reciprocal cone. Then we discuss about right circular cone and how to find the vertex of cone. So these are some important parameters under this cone chapter, right? So whatever the question posed, which will come under one of these categories. So please take a note of that. After noting, please tell. So here we are calculating vertex of a cone. So can I start now with the definition? Right. So if we think about what is meant by a cone, we simply say that cone is a surface generated by a straight line. Right? So in a simple way, you take a fixed point V in the space and you consider a straight line passing through it. The another property of this straight line is it touches a given curve. So you can say it intersects a curve or touches. So if you consider set of all straight lines passing through one point and intersecting a curve, so all these lines collectively together generates a surface. That surface we are calling it as a cone. So every line on this surface passing through the point V, we call it as the generator of the cone. So here a cone will contain infinite number of generators. Now what happens? The condition the generator is satisfying, or the curve where the generator is intersecting, that we call it as base curve or guiding curve. So this is all about the definition of a cone. So any questions or any doubts for anybody? So in a simple way, cone is a surface generated by a straight line. The surface, if you consider, every straight line on it passes through a fixed point and intersects a given curve. This given curve, we are calling it as the base curve or guiding curve. So in a simple view or visualization, if you think of, you just take an ice cream cone. This is nothing but the vertex of the cone. If you consider a molding thing like this on its surface, we call it as the base curve or guiding curve. Now, is this visualization clear to all? How a cone is forming? Say, any doubts? Right? Now, if we look at the properties of the cone, every homogeneous equation in the variables x, y, z having any degree, that we call it as a cone whose vertex is origin. So in other words, we can say that every homogeneous equation of degree n in the three variables x, y, z will represent a cone whose vertex is at origin. So for a small convenience, I will write the equation as so you consider this equation. Now, can you say that is it homogeneous or not? And what is the degree of it? Because every term has power 2. So this is a homogeneous equation. It will represent a cone with vertex at origin. So will it definitely represent a cone or not? For that, we will calculate a determinant. If the determinant is equal to 0, then we can say it will represent a cone like that. Fine. So the fundamental thing we need to remember here is, if you take any homogeneous equation of any degree, either second degree, third degree or nth degree, then such type of homogeneous equation will represent a cone. The vertex will be at origin. From this equation, we are going to deduct one more small equation. Before that, we need to remember one condition, that since if you understand the definition of cone, it contains infinite number of generators. So generator is nothing but by default a straight line which is lying on the cone. So what happens if you say that L, M, N or the DCs of the generator, these DCs will satisfy the cone equation. In other words, if you say you have a cone equation, say f of xyz, then if you consider any generator of the cone which is written in the symmetric form, let me say x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. If you want to check whether this line is a generator of the cone or not, you simply substitute Lmn in place of xyz here. Then obviously you should get 0. That means the DCs should satisfy the cone equation. If this is happened, then we can say that the line what you have taken is a generator of the given cone. Okay, so you please take a note of this. The DCs of the generator must satisfy the cone equation. Clear? Fine. Now, the another result what I am going to deduce here is so you consider the equation ax square plus by square plus cz square plus this equation, which is a homogeneous one. Obviously, the vertex of the cone is nothing but origin. Suppose this equation has three mutually perpendicular generators, nothing but you say that this cone passes through the three coordinate axes, x-axis, y-axis, z-axis. Now what happens, as per the previous result concerned, the DCs of the generator must satisfy the cone equation. So the DCs of x-axis are nothing but 1, 0, 0, for y-axis 0, 1, 0, and for z-axis 0, 0, 1. So if you substitute 1, 0, 0 in place of x, y, z here, you will get that A is equal to 0. Will you agree? Please check. If you substitute 1, 0, 0 in this equation, you will get that A is equal to 0. Similarly, if you substitute the DCs of y-axis and z-axis here, you can say that B is equal to 0 and C is equal to 0. As I have taken that, this surface represents a cone, the vertex is origin, and if it has the three coordinate axes as generators. So x-axis is a generator, y-axis is a generator, and z-axis is a generator. So the DCs must satisfy the cone equation. Hence I am substituting the DCs values. As a result, I am getting that A is equal to 0, B is equal to 0, and C is equal to 0. So it will be reduced as 2hxy plus 2fyz plus 2zx equal to 0. So cancelling 2, you can say that fyz plus gzx plus hxy equal to 0. So this equation, we have to remember that whenever a cone with vertex at origin and passes through the three coordinate axes, this is the formula or equation for it. The cone having the three axes as generators, for which this is the formula. Okay, so please take a note of it. Clear? After noting, please inform. Now we do some problem solving techniques. The three x-axis, y-axis, z-axis always perpendicular, isn't it? That's it. It has three mutually perpendicular generators that you can say. Right. So up to this part, anybody has any queries with regard to the definition or concept what we have discussed to all of you? Or is that clear? Now, the problem what we are doing is, if vertex is given and base curve is given, then how to calculate the cone equation or how to evaluate the cone equation, right? Now, the problem is, I have taken that the vertex of the cone is 1, 2, 3 and the base curve of the cone is y square equal to 4ax and z equal to 0. So here we need to understand that this is a parabola, z equal to 0 is the plane, the xy plane. So the parabola and xy plane both will intersect. That intersection is nothing but a curve here. So in other words, at the point 1, 2, 3, if you draw a straight line, this straight line is intersecting this curve. In other words, if you take any point on this curve, this point commonly belongs to both the things, because the curve is formed by means of the intersection of these two. So this curve, we are calling it as the base curve or the guiding curve. Now how to evaluate the cone equation here, that is the task. Okay. I will describe the procedure. Now you are going to evaluate on your part. Clear? Are you able to visualize that? How we are framing a cone? And understand one more thing, that whenever we talk of base curve, it may be the intersection of any of two: parabola, plane, ellipse, plane, and another things. Base curve generally may be either circle or hyperbola or parabola, any of the kind. You should not fix that base curve must be of this shape. You cannot say like that. Generally we get a circle always. Now understand that cone is nothing but a surface generated by a line. So first of all, you write the equation to the generator. So generator is nothing but you are writing the line equation. So let us say that this is the vertex and you take that LMN or DCs of the generator. So the equation of generator is x minus 1 by L equal to y minus 2 by M equal to z minus 3 by N equal to R, say. So which gives that x equal to LR plus 1, y is equal to MR plus 2 and z is equal to NR plus 3. So what does it mean? Every point on this generator must be of this form for some R. So for a particular value of R, you will get a point on the base curve. Accepted? Say. So this point will satisfy the base curve equations. So I can substitute the values in either of the two, both the things, because this point commonly belongs to the two things which are given there. So if you substitute this value here, from this you have nr plus 3 is equal to 0, which gives that r is equal to minus 3 by n. If you substitute the values here, you have mr plus 2 whole square is equal to 4 into a into lr plus 1. Are you getting the idea? How I am substituting the values there? Say. By taking confirmation from your side, then I will move ahead. Right? Now, in place of r, you substitute the respective value here. So you have m into or minus 3m by n plus 2 whole square is equal to 4a into minus 3l by n plus 1. So if you take LCM here, you will get that 2n minus 3m whole square is equal to, if you take n square to this way, n gets cancelled, so you have 4an into n minus 3l. Please check the simplification. Agreed? Yes or no? Now, please understand that this is the equation satisfied by LMN, the DCs of the generator. From the generator equation, please understand that the values are proportional. So x minus 1 L proportional, y minus 2 m proportional, z minus 3 n proportional. So from the equation of the generator, in place of LMN, we will substitute the respective values. So this is nothing but 2 into z minus 3 plus 3 into y minus 2 whole square plus 4 is equal to 4a into z minus 3 into z minus 3 minus 3 into x minus 1. That was the thing we do. So how I have taken? I have taken the values of LMN as x minus 1, y minus 2, z minus 3. These are taken from the generator. The rest of the part is nothing but just simplifying this equation. Expand it using a minus b whole square, a plus b whole square. Simplify that, you will get the respective equation. That is nothing but the required equation of the cone. That's it. So did you get the concept now, how we are solving? So if the idea is clear, let me take the other problem on the same model. Then you get the clear-cut overview how to solve or how to calculate the equation of a cone when base curve and vertex are given to us. Okay? After noting this, please tell. So in place of LMN, for L we are substituting x minus 1, for m y minus 2, for n z minus 3, because the values are proportional. The values are proportional. Because from this you can say that L is equal to x minus 1 by r, isn't it? So if R is 1, L is nothing but x minus 1. Agreed? That's why I am taking the thing. So the numerator values are by default nothing but the values of element. Right. Now can I erase this? Okay. The next problem is I have taken the vertex as 1, 1, 0 and the base curve is given as x square plus z square equal to 4. Now let us do it together. So first of all, I have to write the generator equation. So it is nothing but x minus 1 by L is equal to y minus 1 by M is equal to z minus 0 by N. This is the base curve I have taken. X square plus z square equal to 4 and y is equal to 0. This is my base curve. So after writing this generator equation, I have to write the parametric constant which gives that x is equal to LR plus 1, y is equal to MR plus 1 and z is equal to NR. So every point on the generator will be of this form. So the point on the base curve will satisfy the two equations which are given here, and also the point is of the same form for some R. So from this you can say that MR plus 1 equal to 0, which gives that R is equal to minus 1 by M. And from this you can say that LR plus 1 whole square plus NR whole square is equal to 4. Substituting R value here, so minus L by M plus 1 whole square plus minus N by M whole square is equal to 4, which gives that 1 minus L whole square, M minus L whole square plus N square is equal to 4M square. Agreed? Now in place of element from the generator equation, I am substituting the respective values, which gives that x minus y minus 1 minus of x minus 1 whole square plus z square is equal to 4 into y minus 1 whole square. So if you simplify, this is nothing but the respective cone equation. On simplifying that, you will get the value as x square plus 3y square plus z square this is the equation of the cone. Minus 3y square or plus 3y square? Yeah. So if you look at the overview of the method, the first step is we have to write the generator equation. In the base curve, always we should consider the plane. So from this plane, we will evaluate the value of the parametric constant. And from this, you have an equation in which we substitute the parametric constant value. After that, straight away we substitute the values in the numerator of generator equation. By simplifying, you will get the cone equation. That is the idea behind it. Okay? Fine. Why I am taking is, in examination point of view, generally question will not be asked on straight away numbers. Let me say the question in general asked as if the vertex is alpha, beta, gamma and base curve is given by say x square plus z square is equal to r square and y is equal to 0, then find the equation of the cone. So answer will come in terms of x, y, z, but it also involves the values of alpha, beta, gamma. Now you can see the difference. So in exam point of view, question will be given like this. So if you solve the problem using numerical values, the numbers, then this method will be very convenient for you to solve. Okay? Is it fine? That's why I am taking. If you are interested, I will take one more problem on this concept, or not required. Fine. Then let us think of the other model. So find the equation of cone passing through three coordinate axes and the lines take a note of this problem. Please understand, is the vertex origin or some other point? It is some other point, right? When the vertex is origin, then you have the chance of getting homogeneous equation. Please understand. That's why you are having a different equation here. Agreed? I will give one more point that, so I just want to give an assignment that gives a good idea of what we are discussing. Take that this is the vertex 5, 4, 3 and the base curve is given by three x square plus 2y square equal to 6 and y plus z equal to 0. You take this problem as an assignment to calculate the cone equation. So what happens if you substitute in the base curve the values, r value will come as the value of r minus 7 by m plus n. So the rest of the part is very similar, you can do it. So on simplifying, the final answer will come like this. Maybe you can check with the plus or minus things. I think the cone equation will come like this. Now you see the vertex is not origin, it is 5, 4, 3. And if you look at that, up to this part this is homogeneous and the remaining is non-homogeneous part. Could you check on that? So it is also a surface which is giving us the cone. So you please take a note of that. That is the answer of that problem. So you take this problem as an assignment or homework, whatever you call it as. If you have noted, then we discuss with this concept. Right. Now, if you want to have a small visualization over this problem, it is just like say this is x-axis, this is y-axis, this is origin, this is the cone we are getting. So this is the cone part. So here you will get y-axis, here you will get x-axis, and z-axis also will come like this. So the cone is passing through 3 coordinate axes. Apart from this, it also contains 2 lines which are given there. In other words, it has 2 more generators. The 2 generators are given there. Then for such cone, you have to calculate its equation. That was the objective. Is it clear? Are you visualizing that? Right. Now, as and when the question contains the word 3 coordinate axes, by default we need to understand that the equation of the cone is nothing but fyz plus gzx plus hxy equal to 0. This is the standard formula. All we need to do is you have to calculate the values of f, g and h. So how to do that? Since it contains 2 more generators, as we mentioned that whenever you have a generator, the DCs of the generator must satisfy cone equation. So you have 1 minus 2 3 will satisfy this equation, 3 minus 1 1 will satisfy this equation. So in this cone equation, in place of x, y, z, I am substituting 1 minus 2 3 and I am substituting 3 minus 1 1. I will get 2 equations. Yes, by default the vertex is nothing but 0 0 0. The very common thing is, if you say that this is the generator, what is the point in the numerator? Is it 0 0 0 or not? Or are you getting any other point? So it is by default origin. That's why I have mentioned that whenever 3 coordinate axes, by default the vertex is nothing but origin. Otherwise you cannot get that. You cannot get the cone equation apart from that. Okay? Right. So if you substitute the things there, you will get the equation as 6f minus 3z plus 2h equal to 0. That is one equation. And the other one you are going to get it as f minus 3z plus 3h equal to 0. By substituting 1 minus 2 3 and 3 minus 1 1 here, you please check whether you are getting these equations or not. Everyone please check on your side. So you have to solve these 2 equations. I think I have given the method. We will write like this: f, g, h, f, g. So 6 minus 3, 2, 6 minus 3, 1 minus 3, 3, 1 minus 3. So f by, I close this part, I will go for cross multiplication here. So minus 9 plus 6 is equal to z by, going cross multiplication you have 2 minus 18 h by, doing this part, minus 18 plus 3. Can you regret this method? What we do earlier? Right. So from that, on simplifying, you will have f by 3 is equal to g by 16 is equal to h by 15. So f value is nothing but 3, g value 16, h value 15. You substitute here, which is nothing but our required cone equation. That's it. I think one problem is enough for you in order to get the idea how to solve this problem. Agreed? Say. Right. So if you are clear with this model, I take the other model. Shall I erase? Problem is, just imagine if a plane cuts a cone, what happens? Imagine yourself. What is the picture or the intersection part for both of that? Base curve. Apart from that, what are the other things that you can get? Circle, all right. Any other idea? Then I request you to just go through the Telegram group right now. I just shared a picture to you. Just go through it once in the Telegram group. I hope that everyone is there in the Telegram group. Just go through that. I have shared a small picture to you. So have you seen the picture there? So from that very perspective, can I confirm that all of you have seen that picture which is there in the group, the Telegram group? Yeah. So from that point you can say that if you imagine that this is a cone, there is a double cone in the picture what I shared. However, if you take only one cone, the plane must cut at any part of the cone, at the vertex horizontally, at the vertex vertically, slightly it will cut, horizontally it will cut the cone at different places. So depending upon the intersection or the plane at which it cut, you will get a circle, hyperbola, ellipse, parabola, and if it cuts the cone vertically at its vertex, you will get two lines. So you can imagine the picture like this. So whenever the plane passes through the vertex of the cone vertically, then you will get two lines. You will get two lines of intersection. Are you getting the imagination from that picture? Say, again, go through the picture one more time. You will get another idea. Please take a close look at that. If any other questions you have, you can ask. You can check for the other image which I have sent there, which gives one more idea. The small picture I have shared another one to you in the group. I think it gives some more little idea. So all these are nothing but the horizontal intersections. If it intersects vertically, definitely you will get a line. Two lines you will get. Agreed? Say exactly. Now here our problem part is, if a plane intersects the cone vertically, you will get two lines of intersection. Now how to calculate the two lines? That is one task. Second, if the lines are given to you, how to calculate the angle between the lines? In a shorter note, we can say you are going to calculate the angle between the lines of intersection of the plane and the cone. That is our task. Fine. Let us do it right now. Are you ready? Okay. The question is, so on observing the very equations plane and the cone, what you can say about that? About the cone, what you can say? Can I say that the vertex of the cone is origin, or the cone passes through the origin? Right, because the plane is not having the constant term, and also the cone equation is nothing but the homogeneous one. So if you say that the plane cuts the cone vertically at its vertex, so the generator, the line of intersection, is nothing but a generator, because the line is formed which is common to the cone as well as the plane. So it is a line lying on the cone and also the plane. Since it is lying on the cone, we call it as the generator of the cone. Now if you calculate the equation of the generator, it is nothing but the lines of intersection. So once you know the two lines, it is very easy to calculate that cos theta is equal to, there is a formula, a1a2 plus b1b2 plus c1c2, that we will apply, right? So the equation of the generator, we write it as x by L is equal to y by m is equal to z by n. Here, please understand that you are going to calculate two set of values for element. One set of values will give one line, another set of values will give the other line, right? As we know, the DCs of the generator satisfy the cone equation. You can say that L square minus 5m square plus n square equal to 0. Please understand that, let me say this is the plane and you have a line on it. So what happens? The normal of the plane is perpendicular to the line. Accepted? The normal of the plane is perpendicular to the line. If you have a doubt with the visualization, go with the picture which is shared in Telegram. When a plane cuts the cone at its vertex, draw a perpendicular line to the plane which is perpendicular to the lines of intersection. So from that you can say that the DRs of the plane and LMN are perpendicular. So you have L minus 3m plus n is equal to 0. This is the other one. Now from that you can say L is equal to 3m minus n. Now let us substitute this value here. So simplifying that, you will get the equation as now I am going to factor this one. Why I am factoring this one? Because you have two lines of intersection. That way this will give two factors for us. Accepted all? Please check with the factors. Agreed? Right. Now I need to calculate two set of element values. How I am getting that? I take this equation and one factor here. Solving these two, I will get element values. Again, I will take solving these two, I will get element values. Please understand that why I am taking a equation considered as the plane equation and an equation taken from the factors obtained from the cone, because the line is formed by means of intersection of the plane as well as the cone. So the element values are obtained from the plane as well as the cone. So I have considered the equation satisfied by element from the cone and from the plane. So these two together constitute the element values of one line. These two together constitute element values of one line. So in this way we will get the two lines of intersection which are formed between the plane as well as the cone. Okay? Are you getting the idea? So if it is clear, then please solve these two. Give me the values of element there. I will say one value you will get them as 1, 1, 2. Another one you will get it as 2, 1, 1. I hope so. I think you are able to solve them by taking the coefficients which we have done already while solving FGH of the previous problem. N is equal to 3. All right. I go with your answer, whatever you say. So 2, 1, 1 is correct. This is 3. Agreed? Fine. So I go with, okay, right, 1, 1, 2, right? So if you apply the formula, this is the formula we apply for calculating the angle value. So if you say that theta is the angle between the two lines of intersection, then cos theta is equal to, that is the formula we use. So you take that this is A1, B1, C1 and this is A2, B2, C2. Now applying that, give me the value of cos theta. What it will be? Can I say that it will be 5 by 6? Cos theta value using that formula. Yes or no? Cos theta is equal to 5 by 6. See, these are the two factors obtained from the cone, isn't it? Right. So while solving, yeah, right from the beginning you want to explain the procedure, isn't it? I will give it. So first of all, that just confirm the value is cos theta 5 by 6 or not. Right. Now let us go with the start again. Now see, this is the cone at which the plane cuts. Now what happens, if you visualize separately, you will get a block like this. So here you will get two blocks like this if you separate the thing. So at this point you will get a line, at this point you will get a line. If you fix a plank here, you will get the intersection, how it is happening, right? Agreed? So whenever a plane cuts the cone at its vertex exactly. Now the two lines are formed. How they were formed? It is the common part for the plane as well as the cone, as and when the plane passes through the vertex of the cone. Since in the cone, if you imagine the shape, it is hollow inside. So what happens, as and when it passes through the vertex, you will get one line at this outer edge, you will get another line at the outer edge. Agreed? While entering and while going out. So you will get two lines of intersection. And how those lines of intersection are formed? It is the common part for the plane as well as the cone. Agreed? Say. Right. So that line is common to the cone. In other words, it is lying on the cone. So it is nothing but a generator of the cone. So I have taken the generator equation. That's why by observing the two cone equations, the vertex is origin, as the plane is passing through origin, I have written the generator equation like this. Since the DCs of the generator must satisfy cone equation, I have written like this. And also understand that if this is the line, the plane normally is perpendicular to it because the normal is coming outside the plane. So you will have a perpendicularity condition that L minus 3m plus n equal to 0. The normal of the plane is perpendicular to the line because the line is lying on the plane. So from this I have taken that L is equal to 3m minus n. Hence I factored the two things. Clear? By substituting L value. Not only L, you can eliminate any one parameter, L, M or N, anything you can do. By substituting here, the cone equation will be factored into two things. While you are factoring, because you will get two lines of intersection. That's why I am factoring it. We are writing it as the two factors product. Now how to deduce the element values? As the line is common to cone and the plane, so I must take this equation mandatory and one factor. In other words, I am trying the line equation on one side. So for one side, plane and cone are mandatory. Similarly, for the other side, plane and cone are mandatory. That's why I have taken two sets as together. This is one set and this is one set. Okay? Is everybody getting the idea why I have taken those two equations only as together to solve? So solving that, you will get element values. So if you want to specifically write what is the line of intersection, one line of intersection is nothing but x by 1 is equal to y by 1 is equal to z by 2. This is one line of intersection. Another one is x by 2 is equal to y by 1 is equal to z by 1. You can check that if you substitute these values in the cone equation, they will satisfy. And also this and this, they are perpendicular. You can check for that. Perpendicularity condition is satisfied, cone condition is also satisfied for these values. You can check that. Because the normal of the plane is perpendicular to the line, the intersection line. Clear? So this is the way we represent the lines. And to calculate the angle, we have the cos theta formula. A1, A2 plus B1, B2 plus C1, C2. For these denominator values, we apply that. From that, you will get the respective cos theta value. Clear now? Say. Yeah. So any Other questions for anybody? Please tell. Just give me a moment. I try to figure out one more picture so that you can have more elaborative idea how a line is forming when a plane intersects the cone. I try to figure that out. All right. Now, let us discuss one more concept, that the concept of enveloping cone, that we will discuss. Because as you have mentioned, it is clear. I will give similar kind of problems for you as a practice so that you can have good idea over this. So, what is meant by an enveloping cone? So from the very word envelope, what is the meaning of envelope? In English generally we talk. What is the meaning of envelope? Can I say that the meaning is nothing but to cover? Say, agreed? So here, enveloping cone is nothing but the cone is formed by means of covering a surface. Say, this is a point and I have taken a sphere here. So, I am drawing the set of tangent lines. So, which will envelop the sphere? So, they will come around the sphere and all these lines are passing through a fixed point. So, this fixed point is nothing but the vertex. Here, the surface is nothing but the base. So, this type of cone, we call it as the enveloping cone. And another name, we can call it as the tangent cone. It has two names. We can call it as enveloping cone as well as the tangent cone. So let me say how to calculate its equation. I'll give the formula straight away. If you say that x1, y1, z1 is the point and S is the sphere generally, then the equation of the enveloping cone is nothing but S1 square is equal to S into S11. This is the formula we use to calculate the equation of the enveloping cone or tangent cone, whatever you say. And these notations already known to you. However, I will write them one more time. So S1 is nothing but xx1 plus yy1 plus zz1 plus u into x plus x1 plus v into y plus y1 plus w into z plus z1 plus d. And S11 is nothing but the number while you substitute the point in the sphere which you get. So if you substitute the point x1, y1, z1 in the sphere equation, you will get a number. The value you are calling it as S11. So S1 square is equal to S11 is the required enveloping cone equation. Now let us take a small problem. So let us say that vertex is origin and the sphere equation is given by x square plus y square plus z square and minus 2x plus 4z minus 1 equal to 0. So let us do a problem on this model. So I want to calculate the enveloping cone where the vertex of the cone is origin and this is the sphere equation. It is enveloping this sphere. So if you substitute the values, so this is nothing but x1, y1, z1 and this is the sphere S. So S1 square is nothing but x into 0, y into 0, z into 0. Here u value is nothing but minus 1 into x. So x plus x1, so minus 1 into x plus 0. V, here v is nothing but 0, 0 into y plus 0. And w is nothing but 2, so 2 into z plus 0 minus 1. This total value whole square is equal to, so S is nothing but x square plus y square plus z square minus 2x plus 4z minus 1 whole minus 1 into S11 is a number. If you substitute 0, 0, 0 in the sphere equation, you will get minus 1. So if you simplify the whole part, you will get the required enveloping cone equation. So I will say that you are going to get it as 2x square plus y square plus 5z square minus 4zx equal to 0. You please check on that. After checking, you please give your confirmation. So please do it on your own. See here, in the place of y, you will get 0. 0 and anything is 0 here. So y, okay, y, that's why, sorry, I just want to make a small correction here. Yeah, here you have y, right? This will come to this place. So once you please simplify and then tell whether you have arrived at the same answer or not on simplifying that. So for a small visualization, you can say that you take a ball, you attach the sticks around the ball and all these sticks are tied to one single point. That you can have a visualization about how the enveloping cone works. That's it. You take a ball, attach all the sticks to it around the ball and all these sticks are tied to one single place. That's it. You are just congruenting them. That is one good visualization. So can you say one real life picture or item where we can make use of this enveloping cone in our real life or daily life, where we see in general the concept of enveloping cone? Can you think of that? Where do we get that? This kind of thing, enveloping cone. All right. So all of you agree with this answer? How we are doing actually with regard to enveloping cone? The solution value, fine. Then I will take, or I will give one or two problems for you as a practice over this finding angle of lines of intersection. So this is one good problem you can do. So this is the cone and plane which are given there. So you need to calculate the angle between them, the lines of intersection. I will give one more. This is also other one. So these two things will give you an idea how to solve the problem. Okay. Please take a note of them. Finding the angle between the lines of intersection of the cone and the plane. So please understand one thing, that if you solve these problems, if you have good idea, so in the next session class, I am going to take some more problems on this concept, the angle of intersection between the plane as well as the cone. And in the next session, we are going to discuss about the right circular cone as well as reciprocal cone both. Then I will take one more session based on your doubts clarified. So there we can conclude the chapter of cones. Cones and cylinder are very simple and small chapters. They won't contain more number of models. They are very simple. Conicoid is somewhat little big. It involves a lot of visualization. That's the only thing. That's it. There we can conclude solid geometry. I will take around 10 sessions it will take to complete whole of solid geometry, that I can say. Okay. So thanks for your good listening. Let us wind up our session here, and in the next session we will meet.